So these next two examples are both about drawing multiple cards out of a standard deck of playing cards. And so for both of them, we're going to have to use one of the multiplication rules that we've been given. And so we're going to either use the one for independent events or the one for dependent events. And so we just have to figure out if our events are dependent or not. And so one thing I want to point out is that the reason I am allowed to write just the probability of B when my events are independent is because when they are independent, these two probabilities are equal to each other. And so I can make that substitution. But again, if they're not independent, I can't do that. And so that's why I have two separate formulas. But so here, this first example is asking us to find the probability of drawing two kings out of a standard deck of cards. And there's another really important piece of information in here, and it's the fact that we're drawing these two cards without replacement. So I'm pulling the first card out, and I'm not putting it back before I'm drawing my second card. And so I need to figure out if those two events are going to be independent or dependent. And so what I'm going to do is I'm going to let A be the event that the first card is king, and B be the event that the second card is king. And I want to find the probability of A and B. So the next part of this example is determining whether or not these events are independent or dependent. And so to figure this out, pretend you have a deck of cards and you pull one out and it's a king. And you look at the king and you say, oh, how cool, and you put it off to the side. There are now not as many cards in your deck of cards, and there's not as many kings. And so when you go to pull that second king, or when you go to pull that second card, the probability of it being a king has been affected by the fact that you've already removed a king. And so that means that these two events are actually dependent. And so that's why I have that written over here. And so now that means that we have to use the formula for dependent events. And so to kind of think about this in words, the probability that the first card is king is really equal to the number of kings in the deck divided by the total number of cards. So that's the first probability. But then for my second probability, I'm essentially going to have the number of kings remaining, right? Because there's only, if I've pulled one out, because this is all in the condition that I've already pulled out a king, and if I've already pulled one out, then there's only 3 kings to choose from, which is the number left. And then I'm also dividing by the number of cards that are remaining, the total number of cards remaining, because it's again on the condition that a king is missing. So number of cards given that a king is missing. I have to make this bigger. And so since, for the first probability, since there are 4 kings in a deck out of 52 total cards, that's my first probability. Then my conditional probability is, well, okay, if I've already pulled a king out, then there's only 3 kings left out of 51 total cards. And so here, I get 12 divided by 2,652. When you convert that to a decimal, you are getting 0.0045. So for the second example, we are now replacing the cards after we draw them, and so we're asked to find the probability of drawing 3 kings. And so here, since I'm putting the cards back, it doesn't matter which card I got the first time when I move on to the second card, because I've put it back. So I still have 52 total cards, I still have 4 kings, and so the probability has not been affected. And so these 3 events are independent. And so when I find the probability of having 3 kings, I can just find the probability of pulling a king 3 times and multiply them. And each of these probabilities is 4 over 52. And when we do that, we get 0.000455. So one important thing to note here is that without replacement means that your events are dependent. But when you're sampling with replacement, your events are independent.